Welcome to The Explainer. I am so thrilled to have you here today. Look, we're going to take a fascinating, high-energy look at how technology is completely transforming STEM education from the ground up. I mean, if you've ever stepped foot inside a high school science classroom, you know the exact vibe, right? The sights, that lingering smell of sulfur, the rigid rows of lab benches. But education is evolving rapidly. And today, we're going to explore how we're moving away from the physical limits of traditional beakers and benches straight toward the absolute limitless horizons of virtual science.
Okay, let's dive into this. I want you to start by just critically evaluating that traditional high school science experience. We all revere the hands-on science project. It's a staple of growing up. But we really have to ask ourselves, are traditional science labs actually holding students back from reaching their full potential? Like, are the physical constraints of a brick-and-mortar room actually limiting how much our students can learn, experiment, and freely explore the world around them?
We all remember this classic science setup. It's incredibly nostalgic. You've got the thick textbooks, the colorful liquids, the fragile glassware, but while this traditional environment is undoubtedly valuable, it comes with some pretty severe inherent boundaries. We're talking about strict time limits. You know, when that bell rings, the experiment is over, whether you finish the last step or not. We're talking about limited and, honestly, sometimes heavily outdated equipment that schools can barely afford to replace. And of course, the very real lab safety concerns that restrict what students are even allowed to attempt in the first place.
So here's how we're going to break this down today. First, we'll look at the limits of traditional labs. Second, we'll introduce the virtual lab solution. Third, we're going to examine the benefits of going virtual. Fourth, we'll peek into the future of science. And finally, we'll see PraxiLabs in action.
All right, let's jump straight into Section 1, Limits of Traditional Labs. We really need to talk about the logistical nightmares of physical science experiments. You see, the pain points here are practically universal across schools, and they go way deeper than just, running out of supplies. First and foremost, safety and security risks. We are literally putting hazardous, highly reactive chemicals into the hands of teenagers. That requires intense, high-stress supervision from teachers. Then there's the cost. It's not just buying the chemicals, it's safely disposing of them and constantly replacing dropped glassware. Plus, access is severely limited by the physical size of the room and the length of the class period. And this leads directly to high failure rates because there's just a total lack of repeatability. Think about it for a second. A chemistry titration can easily take 40 minutes just to set up. If a student messes up, a single drop at the very end, there isn't time or material for a second try. They just fail the lab. Couple that with the massive time constraints placed on teachers who have to prep and clean up all this stuff for hundreds of students, and you start to see how these hazards fundamentally restrict genuine scientific exploration.
So, how do we fix this? Let's pivot to Section 2, the virtual lab solution. It is time to introduce the hero of modern STEM education.
So the crucial point is that a virtual science lab is not just a video of an experiment that you passively watch on a screen. No way. It is a fully interactive, entirely risk-free digital environment. It allows learners to perform experiments literally as many times as they need to without a single ounce of wasted material. They can visualize abstract ideas in a way that just isn't possible in a physical space, like visualizing the exact moment chemical bonds break and reform. You can't see that with the naked eye. And most importantly, it allows them to master complex scientific principles at their own unique pace. This is a total ground-up transformation of the learning process.
Because ultimately, effective science education isn't about the busy work. Instead of mindlessly following a checklist like a cookbook just to get a passing grade, experiments become true inquiry. Students start asking, hey, what happens if I double the temperature? Or what if I remove this catalyst entirely? They can safely, quote-unquote, break the experiment just to see what happens. They utilize collaborative digital tools and formative assessments right in the middle of the lab. They're forced to deeply grasp the why behind the science, which makes reflection a core part of the process, rather than just a rushed afterthought when everyone's packing up their backpacks.
Let's move into Section 3, Benefits of Going Virtual. Why are schools rapidly making this shift right now? And this brilliantly illustrates the stark contrast between the two models. On one side, physical labs mean high operational costs, dealing with hazardous materials that demand strict supervision, and learning that is hard-locked to specific lab hours. If you miss lab day because you were sick, you miss the learning, period.
On the flip side, virtual labs operate on highly cost-effective subscriptions. They carry exactly zero physical safety risks. Literally, no one is getting burned or exposed to toxic fumes. And perhaps most importantly, they offer 24/7 accessibility. If a student wants to practice their physics simulation at 10 a.m. on a smartphone before a big test, they totally can. We are completely trading danger and scarcity for absolute safety and abundance.
That brings us to Section 4, the future of science. We are talking about a full transformation of how science is taught globally.
Now, what's really interesting about this slide is this massive statistic right here. A staggering 72% of educators expect hybrid learning to dominate the future. This means virtual labs aren't just going to completely erase physical labs. Rather, they are going to work together dynamically. Students will prepare and practice virtually until they achieve genuine mastery without wasting any resources, and then they'll take those finely tuned, deeply understood skills and apply them in a physical space.
This future is basically built on 4 escalating technological pillars. Number 1, as we just discussed, is the hybrid learning standard. Number 2 is AI-powered personalized learning. Guys, this is an absolute game changer. AI tutors can monitor a student's virtual experiment step by step, detect exactly where they are struggling, and instantly adjust the difficulty or offer real-time guidance. Number 3 is immersive technologies like AR and VR. Imagine just walking around the 3D structure of a complex protein or interacting with simulated physics engines using haptic feedback so you actually feel the forces at play. And number 4 is learning without boundaries. This technology completely removes geography as a limitation. A student in an underfunded rural school now has the exact same state-of-the-art lab equipment as a student in an elite private academy. It entirely levels the playing field for global STEM education.
So let's see how this all builds into our final section, Section 5, PraxiLabs in action. Let's move beyond memorization and look at a real example.
When students log into a platform like PraxiLabs, they're instantly immersed in highly realistic laboratory conditions. Whether they're extracting DNA in biology or calculating kinetic friction in physics, the interface actually guides students through the procedure. It helps them avoid incorrect choices while constantly testing them on key results. It forces students to actively perform the work, moving them far, far beyond simply memorizing textbook definitions and just hoping for the best on exam day.
When you look at the core value proposition of a platform like this, the benefits are just incredibly clear. It provides safe, risk-free simulations and enables unlimited repetition. A student can run an experiment 50 times until it finally clicks in their head without wasting a single drop of expensive chemical material. It greatly reduces a school's dependency on securing physical equipment year after year, and because of that hands-on virtual practice, it massively improves concept retention. Plus, it offers consistent, accurate results every single time, all while giving teachers these amazing automated back-end tools to effortlessly track student performance and step in right when help is actually needed.
And honestly, what I love most about this is the skills it built. They are highly transferable. We aren't just teaching kids how to click and pour liquid from a virtual beaker. We are actively building critical thinking, rigorous data analysis, creative problem solving, and scientific observation. These are the exact digital literacy skills they will absolutely need to thrive in the modern workforce, no matter what career path they ultimately choose to go down. So we've seen the physical limitations of the past, the incredible flexibility of the digital present, and the AI-driven, highly immersive future of STEM education. And it all leads us to one final, very important question to leave you with today. Is your classroom ready for the virtual revolution? Look, the evolution of science education is undeniable, and the tools to make learning limitless are already right here. The only thing left to do is log in. Thank you so much for joining me for this explainer. Keep exploring, keep questioning, and I will catch you next time.